Welcome to today's daily paper drop. Computer vision absolutely dominated the AR-14 submissions, showcasing rapid advancements. Machine learning and computation and language also maintain strong presences, highlighting continued innovation in core AI fields. Let's dive in. Let's dive into our first paper, MobileO, Unified Multimodal Understanding and Generation on Mobile Device. This work addresses a critical challenge, bringing powerful multimodal AI, capable of both understanding and generating visual content, to resource-constrained mobile devices. Existing models are often too large and data-hungry for edge deployment. MobileO introduces a compact vision language diffusion model that achieves this feat. Its core innovation is the Mobile Conditioning Projector, or MCP, which efficiently fuses vision language features with a diffusion generator using depthwise separable convolutions. This design ensures minimal computational cost while enabling robust cross-modal conditioning. Trained on millions of samples, MobileO significantly outperforms prior unified models in both speed and accuracy on mobile devices, making real-time, on-device multimodal AI a practical reality without cloud dependency. Next up, we have a very big video reasoning suite. While video models have advanced rapidly in visual quality, their reasoning capabilities often remain underexplored. This paper highlights that systematic study of video reasoning and its scaling behavior has been hindered by a lack of large-scale training data. To fill this gap, the authors introduced the Very Big Video Reasoning, or VBVR, dataset. This unprecedented resource spans 200 curated reasoning tasks and over 1 million video clips, making it orders of magnitude larger than existing datasets. Complementing this, they present VBVR Bench, a verifiable evaluation framework that uses rule-based, human-aligned scores for reproducible and interpretable diagnosis of video reasoning. VBVR promises to accelerate research into truly intelligent video understanding. Our third paper, Skill Inject, Measuring Agent Vulnerability to Skill File Attacks, uncovers a critical security concern for the rapidly evolving LLM agent ecosystem. With agents increasingly leveraging skills, specialized third-party code and instructions, the supply chain for these systems becomes more complex, introducing new attack surfaces. This paper identifies skill-based prompt injection as a significant threat. They introduce Skill Inject, a benchmark designed to evaluate the susceptibility of widely used LLM agents to injections hidden within skill files. Their findings are sobering. Frontier LLMs show high vulnerability, with attack success rates reaching up to 80%, often leading to harmful actions like data exfiltration. This work underscores the urgent need for robust, context-aware authorization frameworks for agent security. Next, we delve into AdaEvolve, Adaptive LLM-Driven Zeroth Order Optimization. The paradigm for automated program generation is shifting towards inference-time search, where LLMs act as semantic mutation operators within evolutionary loops. However, current systems often use static schedules, leading to wasted computation when populations stagnate. AdaEvolve addresses this by reformulating LLM-driven evolution as a hierarchical adaptive optimization problem. It uses an accumulated improvement signal to dynamically modulate exploration intensity at a local level, reallocate resources globally via bandit-based scheduling, and generate novel solution tactics through metaguidance when progress stalls. AdaEvolve consistently outperforms open-sourced baselines across 185 diverse optimization problems, demonstrating a more efficient and effective approach to LLM-guided search. Our fifth paper, Align When They Want, Complement When They Need. Human-centered ensembles for adaptive human-AI collaboration, tackles a fundamental tension in human-AI decision-making. Designing AI to complement human weaknesses can boost performance, but often erodes trust if the AI contradicts human strengths. Conversely, an aligned AI fosters trust but might reinforce suboptimal human behaviors. This paper introduces a novel, human-centered adaptive AI ensemble that strategically toggles between two specialist models, an aligned model for trust building and a complementary model for performance boosting. Using a simple yet provably near-optimal rational routing shortcut mechanism, this ensemble adapts to contextual cues. Experiments show this adaptive approach yields significantly higher human-AI team performance than single AI models, offering a promising path for more effective collaboration. Moving on, we have barrier steer, LLM safety via learning barrier steering, a crucial contribution to making large language models safer and more reliable. Despite their advanced capabilities, LLMs remain vulnerable to adversarial attacks and the generation of unsafe content. This paper introduces BRRSTR, a novel framework that embeds learned nonlinear safety constraints directly into the LLM's latent representation space. It employs a steering mechanism based on control barrier functions, or CBFs, to efficiently detect and prevent unsafe response trajectories during inference. Critically, this is achieved without modifying the underlying LLM parameters, preserving original model capabilities. Barrier steer provides theoretical guarantees and substantially reduces adversarial success rates and unsafe generations, offering a principled and computationally efficient approach to LLM safety. Our next paper, Causal Flip, a benchmark for LLM causal judgment beyond semantic matching, addresses a critical limitation of current LLMs, their tendency to rely on spurious correlations rather than true causal understanding. While LLMs perform well on many reasoning tasks, this success can often stem from memorizing semantic patterns. Causal Flip is a new benchmark designed to push LLMs beyond this, encouraging the development of models grounded in causality. It features causal judgment questions built over event triples that form different causal relations. Crucially, it constructs pairs of semantically similar questions that reuse events but demand opposite causal answers, systematically driving models reliant on semantic matching towards incorrect predictions. This work reveals that even explicit chain-of-thought reasoning can be misled, highlighting the need for internalizing causal reasoning steps. Let's explore CQCIM, hardware-aware embedding shaping for robust CM-based retrieval. Deploying retrieval-augmented generation, or RAG, on edge devices is highly desirable but faces significant challenges due to data movement and computation latency on traditional architectures. Compute in memory, or CIM, offers a promising solution by performing vector search directly within its crossbar structure. However, a fundamental representation gap exists. High precision, high dimension embeddings are incompatible with CIM's low precision, low dimension constraints. CQCM introduces a unified, hardware-aware data shaping framework that jointly learns compression and quantization to produce CIM-compatible low-bit embeddings for diverse CIM designs. This is the first work to comprehensively shape data for CIM-based RAG, effectively bridging the representation gap and unlocking efficient RAG deployment on edge devices. Our penultimate paper, Machine-Generated, Machine-Checked Proofs for a Verified Compiler, Experience Report, presents a fascinating case study at the intersection of LLMs and formal verification. With LLMs transforming software development, the question arises, can they also generate machine-checked proofs of correctness? This paper reports on using an agentic coding assistant, Claude Code, to mechanize a substantial correctness proof for the administrative normal form transformation in the Certicoke verified compiler. With human guidance but no human proof writing, the LLM developed approximately 7,800 lines of ROC proof in just 96 hours. This achievement, significantly larger and faster than a human-written counterpart, highlights the profound potential for LLMs to generate not just code, but also formal guarantees, paving the way for a future of machine-generated, machine-verified software. Finally, we conclude with a thought-provoking paper, The Digital Gorilla, Rebalancing Power in the Age of AI. This work argues that contemporary AI policy suffers from a categorical error, analogizing AI to existing technologies like products or platforms. Instead, the authors propose that certain advanced AI systems function as de facto centers of power, shaping information and coordinating behavior at scale. They introduce the concept of the digital gorilla, treating these systems as a fourth societal actor alongside people, the state, and enterprises. The paper develops a for societal actors framework, mapping power flows across economic, epistemic, narrative, authoritative, and physical modalities. This reframing shifts the governance inquiry from controlling a risky technology to designing institutions capable of accommodating powerful digital systems while preserving democratic legitimacy and the rule of law.